All right, y'all. So we're back. I know we're not going to be physically in school anymore, but I told everybody who emailed me that it's going to take a little more than the Ronas to stop me from being your teacher and to stop me from being extra. We have one unit left, so we're going to do it on YouTube. All right? So every Monday, I'm going to post a new video for a new section for our last unit. All right? Then go on Google Classroom and there's going to be practice, there's going to be worksheets, there's going to be Quizlets, Kahoots, stuff for you guys to do so that we can stay smart and we can finish, okay? So I'll be on here every Monday, and then every Tuesday on Instagram Live, I'll be here for questions. So what I want y'all to do is watch my videos, try to do the work on your own, but on Tuesday at 1 o'clock on Instagram, I'll be there if you guys have any questions and y'all can ask me directly. All right. So follow me on STEM things, STEM_things. And I do a lot of cool stuff on there now. So I know I was slacking at the beginning of the year and I was just busy and I was tired. But we have all the time in the world now. So we're doing shout outs. I'm asking y'all questions. Science and chill is still a thing. We're watching Night on Earth every Thursday. I go live at 12:45. We press play at 1 o'clock. If you're late, you're late. And just like STEM things, no. And just like at school for Science and Chill, we'll talk about whatever. Like, we just have a good time, all right? Because I miss you guys. So that's all the updates. That's all information I have. If y'all have any questions or your parents have questions, as always, email me and I'll try my best to get you an answer. So let's get to this thing. All right, let's do it. Okay, so if you see me looking down, here's what we're doing. I got your textbook that all of y'all should have. So I told y'all to take it day one. All right. And as always, everything I'm talking about, I pretty much just went through your book and I was like, what does the book say they need to know? What do I think they need to know? And we did that. I also have the notes. Ooh, it's bright. There you go. So all the notes are going to be on Google Classroom. They're also going to get printed out and put in the packets for those of you that don't have internet all the time. I know there's going to be some sort of packet distribution. And so everybody gets the same notes. So that's what I'm going off of today. And so the first thing we're going to talk about is we're going to be talking about static electricity. That's going to be our first little section unit for this week. So the first thing that I put in you guys' notes is that I always, just like usual, want to link it to something like, why should we care? Like, why do we even want to know this? And I feel like electricity should be something that everyone should be pretty appreciative of because it runs your phone, AirPods, your laptops. The whole reason y'all aren't as bored as you think you are in quarantine is because we have things like Netflix, we have the internet, and without electricity, none of that would happen. And so we're going to spend this unit really taking our time to understand how does electricity work, how do magnets work, and how do they affect our everyday lives. And so the example that I give you guys in your notes is about how magnetism and electricity protect us from the number one hater that's out there in the world. And so I'm not going to read it for you because I want you to read your notes. So for your first chance for a shout out on STEM things, go on STEM things. I'll put up a post. I want you to comment Planet Earth's number one hater, and I'll give you a shout out in my story. The next thing you'll see in the notes is the vocab roll call. And so those are going to be all the vocabulary words that I'm going to talk about in this section. And these are the definitions straight out the back of the book. All right. So if you're reading through the notes and something's funky and it doesn't look right and you don't understand, take some time, look at the vocabulary. You don't even have to go through the back of the book anymore and just read through your vocabulary. All right. So the back of the page. So if any of y'all have the paper copy, please always flip to the back. I warn you at the bottom, but it's there. It's on the back. All right. So when we talk about electricity, right? When we talk about electricity, we have to start off from the very basics at the very bottom. And so we're talking about the most basic things that we need to know about electricity and where it comes from and where it's made up of is we have to talk about electrons. So you guys remember that atoms have three basic parts. You have protons, which are positive. You have neutrons, which are neutral. And then you have electrons, which have a negative charge. All right. And so electricity is pretty much the flow of those charges, those positive and negative charges, and how they interact with different objects. So when we're talking about a flow or a change in charges, if you guys think about how an atom is set up, the protons and neutrons are stuck in the middle in the nucleus, and the electrons, remember we talked about the cloud, like the toddler running through the backyard, they're the ones free running around all over the place. And so electrons are what make objects positively or negatively charged. All right. So when we're talking about charges moving from objects to another, it can be confusing because when I say something's positively charged, you might think it has more protons, but remember those protons are stuck. And so what that really means is that it lost electrons, okay? So when we're talking about electricity and magnets, just another key important thing is that positive and negative charges, we talk about things attracting and repelling. So when things are the same, so two positives or two negatives, they're going to repel each other. All right, they're going to want to move away from each other. But if you have two opposite charges, like a positive and a negative, they're going to attract each other and they're going to want to come together. All right. So the interaction between these positive and negative charges, like I said, that's what electricity is. And so earlier in the year, we talked about force, and one type of force is electric force. So electric force is the force between positively or negatively charged objects. Okay? And when we talk about that force, remember when we talked about gravity and gravitational force, and we talked about how everybody's mama, we talk about everybody's mama, has a gravitational field. So just like that, all objects have an electric field. Some are just stronger than others, and we can see the effects of that. So the area around a charged object where you can feel its push or pull, that is the electric field. And that push or pull you feel is the electric force. So the closer two objects are to each other, the stronger that force is going to be. And the farther apart they are, the weaker that force is going to feel. All right. So the electric field, like I said, it is invisible. However, scientists use lines and they draw lines to express that force or to represent it. So just like when we talked about force before and we said the arrows let us know the direction of force is going and the size of the arrow lets you know how strong that force is the exact same thing when you're drawing an electric field. Remember in electric field we talked about positive and negative charges? All the electric field arrows point away from positive charges and they always point towards negative charges. So remember, it's away from positive charges and towards negative charges. Most objects have a neutral charge out in the world, all right? So a lot of stuff we see and you touch every day, it doesn't shock you. It's not electrically charged because there's a balance of positive and negative charges, a balance of protons and electrons. However, that can change, remember, from moving electrons. So remember, like we said, the protons are stuck in the nucleus and the electrons can run around. So when an object gets an increase in the number of electrons, it becomes negatively charged. And when an object loses electrons, it becomes positively charged. And when we talk about static electricity, which is the first type of electricity we're going to talk about, static electricity is when negative charges build up in an object and they don't go anywhere. All right, they're not free flowing around. They're just chilling and waiting, and we'll talk about what they're waiting for in a minute. So we have a law, another law, all right, is going to be the law of conservation of charges. I'm going to give y'all 3 seconds for y'all to think about what y'all think it says. All right. If you with me, you should know. If you don't know, I'm a little disappointed. All right, just a little bit. It says the same thing every other law says. Every law of conservation of everything says blank cannot be created nor destroyed. So the law of conservation of charges says that charges cannot be created or destroyed. All they do is move around. So electrons don't just disappear, poof, away, or do they just poof, reappear. They just move from one object to another. And when they move, that's what changes charges. So there's 4 different ways that you can build up static electricity in an object, all right? Or you can change where the electrons are that create static electricity. So the first is by friction. And so we remember friction is when 2 objects rub together. So if you think about rubbing your socks across carpet or rubbing a balloon on your sweater, those are the things that are going to create static electricity by friction. The next is conduction. And so conduction is when you build up static electricity by touching things. I know you guys have seen those giant metal spheres, and I'll try and insert a picture if I learn how to edit in my life. But these giant metal spheres, and they have like static electricity, and you'll see them at like science events, and you touch them, and when you touch them, like your hair will stand on end or your arm hairs will stand on end, and you can feel that static electricity moving from one object to another through conduction, through touching. All right, just like heat transfer through conduction is touching, it's the same thing with static electricity. The third is induction. So induction is a little bit more complicated. So induction is when electrons move within one object because it's close to another object's magnetic field. All right. So when you have one object that's close to another, and it causes that object's internal electrons to move around. Not because they touched, just because they were close together. And so that's going to be what induction is. And then polarization is also sort of more internal within an atom structure, or within like a molecular structure of like a molecule. So that happens when individual atoms or individual molecules react to a magnetic field, and it creates a negative end and it creates a positive end. All right. So the thing that I want you guys to remember about that as a really good example is, I know in 6th grade you guys talked about characteristics of water and water molecules, and you'll remember water molecules are polar. The oxygen side is slightly negatively charged, and the hydrogen side is slightly positively charged. So remember, it looks like Mickey Mouse ears. All right. So the ears are the hydrogens that are positively charged, and then your face, your beautiful, beautiful face, that is the oxygen side that's negatively charged. And so that's a really good example of polarization. When these electrons are stored up and they're not really moving and they're chilling, that is static electricity. And so I told y'all they're just sitting and they're waiting, and they're waiting for something. And what they're waiting for oftentimes is there's maybe a slightly more positive object that gets just too close. And remember, opposites attract and alike repels. So those electrons, they want some space. They need something to move. So when this positive object gets close enough, they're going to jump from one object to another. And that's called static discharge. All right. Static discharge is the loss of static electricity as electric charges transfer from one object to another object. Yes, I was reading the definition because I didn't have time to memorize it. And it's on the notes. And guess who else can read the notes? You. So a couple of examples of static discharge are going to be things like lightning. Lightning is a very dramatic example of static discharge. A spark is actually one of the indicators that you have static discharge. Other examples are going to be things like when you're scooching across, a room with carpet and your socks and you touch someone and you shock them, or you reach out to touch a door handle and it shocks you. Those are examples of static discharge. And so it's all about that static electricity rapidly moving from one object to another object. Because remember, you have all those electrons in one place and you have this slightly positively charged object on this other side. All right? And the opposites attract, so they're going to jump from one place to another. Okay? So this is it. That's all of it. I'm done. This is it for the week. So just remember, I will be doing Q&A on tomorrow, on Tuesday, 1 o'clock, Instagram Live. If you want to put questions in the comments, I'm going to try and keep up with the comments. I'm going to see what happens. But y'all know me. So it's best to get my attention while you have my attention. So switch over to Instagram. Follow me at STEM_things to do that Q&A and to watch, Earth at Night with me. I miss you guys. So bye. Love you guys.